Hello everyone, my name is Guilherme Magalhães and I'm here with my colleague Carlos Petry to present today a session for the SAP EPM webinar series. Today we are here to talk about SAP Business Planning and Consolidation version for NetWeaver, and the topic will be General Performance and Configuration.
Hello everyone, I'm Carlos and I'll be talking with you a little bit about the general performance and configuration. Bear in mind that we're not gonna go throughout advanced topics. The idea is to present some basic settings and to configure some specific entries that will help you understand a little bit better the architecture of the product. Like we'll be looking only at the server side, all tier levels. This is our agenda for this session. We'll be talking about operating system configurations, database, ABAP application server, and BPC specific configurations. But before we actually dive into these sections, it's important when we're reviewing performance that prior to do any changes, that we do some benchmarks and have some baselines so we actually can test and identify if our changes indeed optimize the performance or not. For that, it's important to reproduce the usage of the product, like running some import data packages, um data manager packages for logic, input schedules, refreshing reports, complex reports, simple reports, running optimization of PPC models, doing some end-to-end tests like including BPF, journals, reports, input schedules as before. So and take note of the time that these actions take to be executed. Also, think of having some type of multi-access simulation, like for example, using HP Load Runner to simulate like heavy system access to understand how this also impacts the performance of the system and make sure you take note of the times these tasks take to run so you can, after changing the parameters, you can identify if you have indeed improve the performance. We'll start by checking the operating system configuration. The OS that we were using here is Windows Server 2008 R2 Data Center x64 edition, Service Pack 1 installed. To access the OS settings and informations, right click on Computer and then select Properties. On a system window that opens, you already have some basic but important information that you have to validate, which is your Windows edition. Make sure it matches what you expected to have installed. The processor, the installed memory, make sure system has recognized all the memory that you have installed, so you have the amount of memory that you're expecting. Also the system type, if it's 64, 32 bits. So once you have checked this, you can go to the advanced system settings. On the system properties, what interests us is the performance. So on the advanced tab, click on settings. On the performance options, the first tab you get is visual effects. Make sure it's adjusted for best performance, as animations and other visual things are not necessary on a server. Second tab is the advanced tab for performance options. Make sure that you have selected background service on server. You're not going to be running foreground applications, like front-end applications. You're gonna always be running background jobs with a heavy system cache usage. So this is a very, very important setting. The other important option on this same tab is the virtual memory. It's the swap file. Uh, if you click on the change button, you receive a screen where you can configure the swap file for every single drive you have. You can leave it to the system to manage it automatically, but to have a very stable server, it's recommended to manually set it. And the best scenario is to have a separate hard drive only to the swap file to ensure it doesn't have any overhead caused by other applications accessing the same drive, and the other way around. The other applications does not have a overhead caused by swap file access. The amount of the swap file you have to set, it actually depends on your RAM. On older systems, especially 32-bit systems where the amount of RAM we could have on a server was limited, we would need to have a bigger swap file to accommodate all the memory needed by the system. But with newer 64-bit systems where you can handle a lot more memory and with the reduced cost of the RAM memory, it's the best approach is to have enough RAM memory to run all your applications, so you actually don't have to go to the swap file to regular activities, only on some heavy loads where you have like out of normal uh, load on the server. The last tab on the performance options is the data execution prevention. On this system, we actually have it permanently turned off by a boot level option, but you can also select here whether you want to turn it on or off. The idea is to have it off since we're only going to be running SAP software on this. We assume that there will be no malicious software, but to be able to decide if can be turned off or not, you have to discuss this with your security team. And but in terms of performance, it's important to keep in mind that data execution prevention will also cause some overhead. For the changes we have done to take effect, you actually need to restart the computer. But since we're going to be changing other settings, please select to once it hits there to restart the computer later. The last item we're going to look at OS level is the fragmentation of the disk. It's important to performance matters, especially where you have applications installed, that the disk is in good shape regarding the fragmentation. Make sure you regularly check the disks by selecting the desired one and clicking on Analyze. It will give you a result of how much fragmented the disk is. Then, if it's necessary, you can defragment the disk. Please keep in mind that this is it's a resource-intensive process. It should not be doing during work hours, like while the system is being used by the server is being used by end users. And you actually also have the option to schedule this fragmentation so it can run nighttime, so it doesn't affect the business process. Next is the database configuration. But before we actually jump into part 2, if you have done any changes on the previous steps, please restart your server now. The database we'll be using on this session is Microsoft SQL Server 2008. And to get to this screen right now, Please open the SQL Server Management Studio and log to it. You can notice that we have different databases on this system, like CMS, DS Theme, but the one that NetWeaver is installed on is the CSA. So this, for now, this is the important database for us. Additionally to the database of the installed applications, there are some default system databases that are important to the normal operation and configuration of the SQL Server. In this case, the most important one is the tempdb, which holds some temporal joins and other structures which are needed during runtime of the database. Note that if the NetWeaver is used as a SAP BW system, the amount of tempdb size you need is much larger than if it's a standard R3 system. Now we're going to look at general database server properties. Notice that we're selecting the top node, which is the server itself, the database server itself. You have to right click it and go on properties. This is the server properties windows, and the configurations done here will apply to all the database inside of this server. Note that database tuning and configuration, it's a very complex task, and using the assistance of a database expert who understands the interactions between the SAP NetWeaver and the database is very, very important and will ensure better results. Just as a simple example, if you're configuring the database to be used by a ERP-based system, the parameters that we'll be setting up are quite different than the same database is configured to be consumed by a BW system. First item we'll be looking at in the server properties is the memory. Here you can set up the amount of minimum server memory and the maximum. So every time the server starts up, in this case 7 gigs of memory will be allocated to the SQL Server, and it can go up to a maximum of 10 gigabytes. In a properly set system, the amount of memory consumed by all the main services on the system should not go above the total RAM available on the system. So in this case, we have the SQL Server and the NetWeaver application server installed on the same system. And on this mathematics, you can also not forget the amount of memory consumed by the operating system. So usually for the operating system, we estimate 1 to 2 gigs, and then you sum up in this case, the SQL Server memory plus the NetWeaver memory, the memory allocated to NetWeaver, and it should not exceed the amount of memory available, amount of RAM available on the server. So you actually don't have to go to the swap file to execute tasks and avoid serious performance degradation. For the processors, the same concept as the memory applies. The amount of processing time allocated to the applications and services running on the server cannot exceed the amount of processing capability available. In this case, the amount of processing time is determined by the amount of working threads. In our case, since the entry is set to 0, the automatic calculation by the SQL Server is used. Since this is a 64-bit computer and we have two processors, the amount of working threads available for all the database is 512. It's important to have enough working threads to suffice all the read and write operations of the database at once. Otherwise, the requests that cannot be handled or do not have a working thread available to be processed will have to wait, and this will greatly impact the performance of the database. The connection set section lets you configure the amount of concurrent connections from the applications to the databases. Remember that this is the amount of all the connections to all the databases. When the application connecting to the database is a NetWeaver system, the usage of the connection is a little bit different, as it's actually controlled by the work process on the NetWeaver. You can see them on transaction SM50 of NetWeaver. Each work process will generate one connection to the database, and inside of database that will allocate a worker thread. So this concurrence, if you only have NetWeaver systems, it's pretty easy to control. We're gonna have at the most the number of connections as the number of the work process in NetWeaver. But since in this case this server is used by other applications as well, you need to keep in mind that the amount of connections coming from the other applications will also have to count on this limit. If you set it to 0, as we have done it here, it means there's no limit to the amount of connections to the server. On the advanced category, we have the ability to set some advanced parameters for SQL Server. Of particular importance is the max degree of parallelism setting. This parameter controls how many processors are used when executing a query plan in parallel. Since we have it set to 1, the parallel plan generation is suppressed. At first thought, you might think we should turn it on. However, this feature is generally only beneficial in specific query plans. Setting it here makes a global effect on the query optimizer within SQL Server, and you may not want all query plans to be executed in parallel, since the overhead of managing the CPU parallelism may outweigh the benefit of executing in parallel. Fortunately, the max degree of parallelism parameter is dynamic, meaning that you don't have to restart database server for it to take effect. This means we can potentially control when to turn it on and off, resulting in a more efficient use of this parallel feature. With SAP Note 1126568, you can actually control this behavior from within the SAP application server, so that start join optimization is used for BI query execution plans only. Typically, BI query can benefit greatly from start join optimization when parallelism is used. Each database that SAP supports, for example SQL Server, Oracle, SAP DB, DB2, has advanced parameters that can be turned on or off to impact normal behavior. Many of these parameters are very specific and require special considerations to determine if they should be or not used. Within SQL Server, there are several special parameters that are not shown in the SQL Server Management Studio. In order to change these parameters, you can use the sp_configure system store procedure. In this session, we will not be changing any of these special parameters, but we want you to know that they do exist and can help in certain situations. As with any complex database issue, you should involve a database expert to help analyze the situation and determine if it will be necessary to use one of these additional settings. You can see the complete list of the SQL Server Advanced Parameters available in the Help menu. Now let's check the configurations specific to the database of our ABAP application server, in this case CSA. So expand the databases inside the server and right click on, our case it's the CSA, but the one that's related to the one you're using, and select properties. Note that even though it looks quite similar to the database general properties, to the global properties of the database server, these settings are specific to to only the database that we're working on this case CSA. So they do not have global impact when changed. On the CSA database properties, we'll be looking at the database files, which is actually our database on the disk, or how it's stored on the disk. In this case, we have 8 data files and 1 log files. Data files are of 8 gigs, and the log files has 6 gigs of size. This is the initial size. And then you have the auto growth option, set or not. And in our case, it's growing by small chunks of 60 megabytes, and there's no limits. For the log file, we have it set by 10%, and there's a restricted growth in this case. You can see that in our case, all the data files are on the same disk, but in a best scenario, they should be separate to improve performance. Actually, understanding the data files of your database can also help you gain optimal performance. In the ideal situation, the data files themselves should be physically mounted on separate drives. This can be implemented using either RAID or SAN configuration, so that the reading and the writing can be done in parallel. The log file should always be placed on a separate drive, so it can be written to while working on the database files. Worker process can be dispatched to look for data among several different data files. So it's important to have evenly distributed data on each data file should be the same size to prevent imbalance. The part 3 of our session is on ABAP application server configuration. BPC is installed as an add-on to BW, so as a consequence, tuning BPC means properly tuning BW as to start off. Just as the database tuning, ABAP tuning is a very complex process, and having a basis and a BW expert involved during this section is something that can greatly improve the results of the process. The first section that we'll be touching about ABAP performance is the memory settings. On transaction ST02, you have a summary of all the memory buffers and statistics sets on the system, including like buffer statistics, amount of swap, program buffer used, table buffer used for storing entries, and all the other options. Next, on transaction ST06, we have the status from the operating system. You can view current and historical statistics of the operating system, like amount of physical memory, amount of free physical memory, how much of page in and page out you had, the amount of swap size, and so on. Now that we have reviewed the operational system summary and memory summary, we can go ahead and start setting some profile parameters. That can be done by transaction RZ10. Select the menu Utilities, Import Profiles of Active Servers. The import will display a check log. Enter transaction RZ10 again and click the drop-down button for the profile. When the drop-down window pops up, double-click on the instance profile. Select the Extended Maintenance button and click on Change. You should see a simple list of profile parameters for the system. You can see many different options here to adjust, like physical memory size, ABAP buffer size, table buffer area, and many others. Once you have adjusted the necessary parameters, in our case we changed, for example, the physical memory to accommodate the memory allocation to the amount of memory available on the server. You have to click on the copy button, then hit the arrow over the green circle, which is the back button, and then you have to save that profile. When you save, an automatic check will run to inform if there are any incorrect parameters. If you understand and are aware of all the configurations that you have done, you can go ahead and skip these errors and say no to the display values. Otherwise, please click yes and review these errors. Then you're gonna receive another pop-up asking if you want to activate the profile. If everything's okay, click yes. Then you should see the following informational message next. Click the green check mark right here, this one. The system will then inform you that you must restart the server for the changes to take effect. Go ahead, open SAP Management Console and restart the SAP NetWeaver server, the whole tree. Next, we will check the logon group. Go to transaction SMLG. Notice that we have created already the logon group public. In this transaction, you can create and modify logon groups for the ABAP application server. These logon groups are for grouping together specific application servers so that you can configure your own load balancing. Load balancing is essential in a distributed landscape, which has more than one instance. This is helpful, for example, if you wish to execute all BPC-related activities on a specific group of dedicated instances. In our case, we have only one single instance. In a real-world scenario, you can have many more instances in your landscape. Each logon group can contain one or more instances. Additional instances would show up in the list under the same logon group, but with different instance names. Double-click on the desired logon group and you'll see the Properties window. You have the logon group assignment and the logon group attributes properties. Now, let's check the background processing server groups. In the ABAP application server, you can also create groups of instances for background processing load balancing. This allows you to execute background jobs on a specific set of instances only. This is helpful, for instance, if you wanted to execute all the BPC background jobs, such as the data manager packages, on a specific group of dedicated instance. For that, go to transaction SM61 and click on the button labeled Job Servergruppen as highlighted on the picture. In the next screen, you'll see a list of the available background processing server groups. In our case, still empty, as you're going to create it during this demonstration. So click on New Group, the highlighted button. We will name our new server group as SAP Default BTC, as on the top picture. Then we have to assign this instance to the server group we just created. Select SAP Default BTC on the server groups and click on the assignment button as on the bottom picture. In the assignment screen, locate the instance for this application server using the drop-down menu. Click Continue when you have assigned the desired instance name. Next, you'll be back to the groups in background processing, and you see your background processing server group SAP Default BTC should be now created. You can see the server and all the remaining information. Now, let's check the RFC server groups. In the ABAP application server, you can also create groups of instance for RFC load balancing. This allows you to execute RFCs on a specific set of instances only. This is helpful, for instance, if you want to execute all BPC parallel scripts on a specific group of dedicated instance. Go to transaction RZ12 and you'll see a screen just like the picture on the left. Here you'll see the default RFC server group parallel generators. Since we do not have a distributed landscape set up for this system, you only see one instance which belongs to this group. You can always create your own RFC server group here, which contains only those instances you want to use for parallel processing. On the right side, you see a picture of the screen where the detail of each server group is shown. By double-clicking on the logon group desired, you're going to get that detail screen. In the app application server, you can set up a cache for the BI queries so that when a query runs on a data selection that has already been cached, the OLAP engine will retrieve the data from the cache instead of going to the database. The OLAP cache can be persisted in a few different ways. For instance, main memory, cluster table, etc. Each mechanism has its positive and negative sides, and an in-depth analysis should be done to determine which setting is the best in your environment. Remember that OLAP cache settings we change here are global for the whole system. But if you want to make an individual settings on an InfoCube or even on an individual query, you can by setting it on the specific object, and it will override the global setting. Using transaction RSR cache, you can see the current configuration of the global cache, and if you click on the cache parameter button, you can edit those. Now, let's see the individual settings on a VPC info provider, which would override the global settings we just saw. Go to transaction RSA1 and find inside of modeling, info provider, business planning consolidation info area, the info area for the environment you are willing to review. In this case, we will use bpcp_xx. Select the desired multi-provider and double click it. A pop-up window with the list of the relevant info providers that belongs to the multi-provider will appear. Click on the green check mark to continue. We will be looking at the OLAP cache for the multi-provider, not the info cube of the planning model, because BPC reports get their data from the multi-provider. The OLAP cache setting we make here only affects this particular multi-provider. This means you can set different cache modes and settings for different BPC environment models or models. Click on menu Extras, Info Provider Properties, and change. A pop-up related to the R3TR will show up. Click the green check mark to continue to the info provider properties. Now on this info provider properties screen, the one on the bottom, you can see that one of the options is the cache mode. Select the desired cache mode, and if you want more explanation about it, you can hit F1 and a description of each cache mode will show up. If you change anything here, make sure you save it. The following slide demonstrates the relationship between the info provider name and the default OLAP query name. All info providers have a default OLAP query name, and BPC NetWeaver uses the query for the multi-provider in order to retrieve data from the InfoCube itself. If we wanted to, this could allow us to further modify the individual cache settings down to the query level itself. I thought it doesn't really matter since there is only one query between on this multi-provider. Now let's look at how we can manage the database from within SAP GUI. Go to Transaction DBA Cockpit. A pop-up will show up describing the transaction. Click Continue. The item that we'll look here as an example is related to SQL Server Setup Check. Double-click on SQL Server Setup Check inside of Configuration folder. This will run a simple check to make sure basic parameters and settings have been made. Another great way to keep general system performance at an efficient level is to run the sgen utility periodically. Sgen is a transaction in which you can schedule the generation of the ABAP programs. Each time a program has been changed or upgraded, you need to regenerate it before you can run. Sgen allows you to generate all the ABAP programs in a parallelized manner. Having to generate ABAP programs can take time depending on the amount of generation needed. So it is important that you run sgen during downtime after big changes such as support package upgrades. Often programs get modified and changed in the system as time goes by. So sgen provides a way to schedule a background job which keeps track of programs that need to be regenerated. We can schedule this job to run weekly or even daily in some cases, so that program generation is always up to date. You can find the below settings by going to transaction sgen, S-G-E-N.
Now we are going to talk about the BPC application configuration. Running a BPC application can depend on many different factors. As with any business application, the model is of the utmost importance. Model discussions will vary depending on the type of implementation you are performing. So this demonstration will only focus on tuning and maximizing BPC throughput and load capability. Tuning BPC reports and input schedules through various modeling and formatting techniques will not be part of this demonstration. So let's configure BPC 10 to take advantage of application server load balancing. BPC communication to the backend happens with a special BPC service user and a special BPC RFC destination. To enable the backend load balancing for BPC10, we only need to set the option in the BPC RFC destination. So go to transaction SM59, select the BPC RFC destination as shown in the screenshot below as BPC underscore RFC underscore DEST and click on the change icon. An important observation, this RFC destination was created and mapped to BPC according to the BPC10 installation guide. For details about this process, please refer to the installation guide. Yes under the load balance section. Change the group to public and click the save icon. Now we will specify a background server group for the BPC data manager packages. In this step, we are showing you how you can specify a background server group for which you want to execute your BPC data manager packages on. This is very helpful if you want to force all BPC data manager activities to execute on a specific set of application servers within your landscape. Remember that this demonstration is only to show you how and where you would change this setting. But because we are only working with a single instance landscape, the configuration won't have any effect. So to do that, you can go to transaction SPRO and click on the SAP reference EMG button. And you can expand the menu for planning and consolidation and configuration parameters and click the execute button next to set global parameters. Click on the new icon, enter the parameter name background underscore server underscore group in the detail screen and click continue. And after that, enter the background processing server group SAP underscore default underscore BTC in the detail screen and click continue. This is the background server group you created in part 3 and it's used when executing data manager packages. Click the save icon. After that, we need to make sure that the BPC global parameter parallel underscore server underscore group has been set, so that BPC knows which RFC server group to execute parallel runs on. When running script logic with the xdin underscore package by keyword, you can designate an RFC server group for which to execute the parallel runs. And after that, you can enter the parameter name parallel underscore server group in the detail screen and click continue. Now you can enter the name server group you created at the beginning of this section, SAP underscore default underscore BTC in the detail screen and click continue. This is the background server group used to execute the BPC script logic parallel runs. After that, you can click the save icon.
As further consulting information, you can review this appendix session. And this list of SAP notes that have related topic fixes and how-to instructions. Thank you for watching this session. Bye.